Okay, today we're going to be looking at absolute value equations. So, 6.5 is all about absolute value, and today we're just going to look at absolute value equations. So by the end of this, we hope that I can solve absolute value equations, and go ahead and put today's date. Now, when we're dealing with absolute value equations, we're going to backtrack for a little bit and just kind of remind ourselves what absolute value is. Absolute value is a number's distance from 0 on a number line. So number's distance from 0 on the number line. So when we find the absolute value and graph the answers on the number line, we want the distance from 0 in both directions. Because if you think about a number line, they go both left and right. So when we find absolute value, we have to go in both directions, left and right. So here's our, and it's just a reminder that absolute value can never equal a negative because distance is never negative. So absolute value can never equal a negative because distance is never negative. Okay. And just lastly, to review absolute value, if we look at an example of absolute value, so I have the absolute value of x equals 5. Alright, so go ahead and copy down this number line. I just went to -5 to +5 on a number line. Because if you think about it, if I have the absolute value of x equals 5, then I want to know what x could be that is 5 away from 0. So we know that 5 is 5 away from 0 because the absolute value of 5 is 5. So if I put a point here and say 5 is 1, 2, 3, oh, 2 there. 1, 2, oh, let's backtrack here. 1, 2, 3, 4, 5 away from 0. But we also know we have to go in both directions. So if I go in the positive direction, I can also say, what's the absolute value of a -5? Absolute value of -5 is also 5. So -5 is also 5 away from 0. So that means that our absolute value of x has two cases. One that's a positive, one that's a negative, because both of these, absolute value of 5 is 5, and the absolute value of -5 is 5. Two numbers give you the same answer. So we have to have two cases. So let's look at our steps then for solving absolute value equations. So our first step is make sure the absolute value bars are alone on the left. Okay, make sure the absolute value bars are alone on the left of your inequality. 2, cannot, not, be equal or less than a negative number. Now if it is equal to a negative number, it's automatically a no solution because absolute value cannot be equal or less than a negative. Step 3, we set up two cases because like we said before, we have one that's positive, one that's negative. So for our first case, the only change to the left side is losing the absolute value bars. That's the only change we ever make to that left side. So the left side of your inequality, the only thing we do is just drop away our absolute value bars. Alright, then for our first case, we set it equal to a positive number. And here's just one quick reminder before I talk about case 2. We lost our absolute value bars, so we don't have absolute value bars anymore. It's just looks like an inequality now. So on case 2, we set it equal to a negative number because it's now outside the absolute value bars. And I'll show that here in a second in the examples. So step 1 equals a positive, second case equals a negative. Alright, step 4, solve each case, and step 5, check. So these are our 5 steps for solving absolute value equations. Step 1, make sure the bars are alone on the left side. Step 2, make sure it doesn't equal a negative. Step 3, set up 2 cases. We lose our absolute value bars on the left, and we set it equal to a positive number. And for our second case, we set it equal to a negative number. Step 4, we're going to solve each case separately. Step 5, check. So here's our first example. We're just going to go through our steps and say step 1, make sure it's alone on the left side. So we're just going to look to this side and say absolute value bars are the only thing over there, so we're good. Absolute value bars are alone on the left. Step 2, cannot equal a negative. Do we equal a negative? No, equal a positive, so we're still good. Step 3, set up 2 cases. So all we're going to do is lose our absolute value bars on the left, which means we're going to say the absolute value of a minus 4 is a minus 4. And our first case equals a positive 3. We don't change it at all. For our second case, we lose our absolute value bars on the left and say a minus 4 is equal to, except this time I change my positive 3 to a negative 3. So I have my 2 cases, one that equals a positive number, one that equals a negative. Now step 4, we solve each case separately. So I'm just going to look at the first case here. So to solve my first case, I'm going to have to transpose my minus 4, making a plus 4. So he disappears. I now have a alone on the left, and 3 plus 4 is 7. Okay? And basically when we solve the first case, the same exact steps we're going to have to use for the second case, except it'll be a negative 3 I have to add. So negative 4 gets transposed to the right and becomes a plus 4. Disappears from the left, and we get a is equal to negative 3 plus 4 is positive 1. So now we have our 2 answers for what a could possibly be, and now we need to check it. So in our check, we're going to have to check both solutions to make sure that both cases work. So we always go back up to the original before we messed with it. A minus 4 equals the absolute values bar. So a minus 4 equals 3. So now we're going to say the absolute value of a is now 7. 7 minus 4 is 3. And the absolute value of 7 minus 4 is 3. So the absolute value of 3, we say the absolute value of 3 is 3, and 3 equals 3, so we check. Now we do the same thing over here. We always go back to the original before we messed with it. A minus 4 equals 3. Except this time I replace a with 1. So the absolute value of 1 minus 4 equals 3. Now we say 1 minus 4 is negative 3, so the absolute value of negative 3 equals 3. And the absolute value of negative 3 is 3. So once again, we're good. We check. Okay, and since both of our solutions check, that means both of these are answers to this absolute value equation. Absolute value equations will always have 2 cases. So let's look at our second example. So step 1, make sure the absolute value bars are alone on the left side of your equal sign. So looking to the left side, they're all by themselves. Now step 2, make sure it equals a positive. So equal a positive, we're good. Step 3, set up 2 cases. So we're going to lose our absolute value bars and say the absolute value of 2x minus 6 is 2x minus 6. In our first case, we set equal to the positive 4. So positive 4. So if you look, basically nothing on the first case changes. All we do is just lose our absolute value bars. Then for our second case, we have the absolute value of 2x minus 6 is 2x minus 6 equals, except on case 2, instead of equaling a positive 4, it's going to equal a negative 4. So now we just solve each case separately. So solve for x, and we have to take my minus 6 and make him a plus 6. So he disappears from the left. I get 2x equals 4 plus 6 is 10. Now to solve for x, we're going to divide both sides by 2. 2's cancel. X equals 5. Alright, so on case 2 we do the same thing. We're going to transpose our minus 6 and make him a plus 6. So he disappears from the left. I get 2x equals negative 4 plus 6 is positive 2. Last step to solve for x is divide both sides by 2. 2's cancel. X equals 1. Once again, for the check, because this is an equation, so we go back up to the original. Alright, we say the absolute value of 2x minus 6 equals 4, except this time I replace x with 5. So 2 times x is now going to say 2 times 5 minus 6 equals 4. So 2 times 5 is 10 minus 6 equals 4. So the absolute value now of 10 minus 6 is 4. And the absolute value of 4 is positive 4, and 4 equals 4, so we check. You do the same thing over here. We go back to our original before we messed with it. And when we substitute x in for 1, so 1 in for x, I'm sorry. So 2 times x is now 1 minus 6 equals 4. So the absolute value of 2 times 1 is 2 minus 6 equals 4. 2 minus 6 is a negative 4, so the absolute value of negative 4 equals 4. Absolute value of negative 4 is positive 4. Remember, absolute value can never be negative, so the absolute value of negative 4 is positive 4, and we check. So once again, these are both our answers. We have x equals 5 and x equals 1 as our solutions. Alright, example 3. We have 5x plus 7. Sorry, the absolute value of 5x plus 7, and then outside the absolute value bars is plus 10 equals 3. So step 1 is to make sure the absolute value bars are alone on the left side. So if I look to the left side of my equal sign, I have a 10 over here with my absolute value bars. So I have to transpose my plus 10 and make him a minus 10. And it disappears from the left. I get the absolute value of 5x plus 7 equals 3 minus 10 is negative 7. Now step 2 says it cannot equal a negative. So we look, and I have that the absolute value bars equal a negative 7. So that can't happen, so it's automatically a no solution. So anytime by step 2 you have your absolute value bars alone on the left side and you equal a negative number, it's automatically a no solution. So that finishes up for solving absolute value equations. Thank you very much.